Hi viewers, I am filming these videos to support teachers of maths in helping making sense of mathematical concepts and ideas with pupils rather than just teaching rote procedure. And in this video, we're going to look at ratio and equation, and particular forming equations from ratio. This is quite a tricky thing for a lot of students to work with. And so I'm going to use a visual representation of that. But as we're going to see in this scenario, this is the place, I think, where we're going to start transitioning away from the concrete and the pictorial if we haven't done so already. So although we're going to start with the bar model, we're not going to finish with the bar model here. And also, if you've seen my earlier videos on sharing with ratio in more simple scenario, like showing where the total is known, showing where the difference is known, showing where the part is known, this is the point, or one of the points, where those multiplicative relationships that we've highlighted, and we're going to highlight again during these videos, is really, really crucial, is really going to come into its own. So we're starting here with a sort of more complicated ratio situation than perhaps students have faced before. And obviously what makes it more complicated, if we look in the question, is that we've got multiple ratios going on. So we've got Tom and Hannah have some money already in the ratio 3-5, but then Hannah gets this extra £6 on top of what was already there. And that, of course, changes the ratio of their money. The ratio of their money is now the ratio 1-2. And we're asked to work out how much money Tom has. So this one, actually, we can sort of explore and make sense of with a bar model. And you can see that I've got the bar model here already set up in the ratio 3-5. I've set it up using the bar modeling tool rather than the Cuisenaire tool with my earlier ratio videos for reasons that will become apparent later on. But we've got that initial ratio already set up. Tom and Hannah have money in the ratio 3-5. So we set this up. And as I always do with kids, I'm going to ask them about the relationship between these two things, the very basic things like, where's Tom? Tom's here because that's the 3 part. Which one represents Hannah's share? Hannah's here because she's got the 5 part. But also, what about the relationships between them? So again, this being 5/3 of this being 3/5 of that. And again, that is going to become absolutely essential later on and with the later question that we're going to look at. So let's track what's happening here then. We've got this money in the ratio 3-5. Hannah has an extra £6 and the ratio is now 1-2. Now, the key thing to notice in this question, if we're going to examine it pictorially using the bar model, is that Tom's money hasn't changed. Tom has the same amount of money in the start as he has at the end. So if we look at this 3 bar here, that 3 has now become this 1 in my new ratio. So what I'm going to do here actually is I'm going to reduce the number of parts in that to 1. That 3 has become that 1. Okay? And now if we look at Hannah's, that has changed. That 1 from Tom, she's now got twice as much. She's got 2. And again, that's part of the reason why these relationships between the parts are so crucial with working with this. Kids need to be able to look at that and see twice as many automatically, see that as 2, twice as much. So actually what we've got here is that scenario. Yeah, this is the start scenario. This is the end scenario where Tom and Hannah have got money split in the ratio 3-5. But when Hannah gets that extra money, we can see this bit is now bigger. We've now got the 1-2. Okay. And so now if we compare these ratio with what we had before by reintroducing the 3 parts here, means we need to reintroduce the 3 parts there and reintroduce, without moving it ideally, the 3 parts there. What we can see is that extra £6 that Hannah's got has increased her number of parts by 1. In effect, what we're doing here is rewriting that ratio 1-2 as the ratio 3-6 and seeing that Hannah's share has gone from 5 to 6. And, if we really want to, we can recolor. Certainly in this bar modeling tool, we can recolor these things to match what Hannah had before. But now, obviously, what Hannah had before was only that. We can see that this ratio and this ratio are the same, except for that one extra part. So that one extra part has a value of 6. In fact, I'm going to add that as a brace there to show it. I need to shorten that brace quite a little bit. That one extra part has a value of 6. That bit there. And of course, from here, it's actually quite straightforward to solve the problem, and we can solve it entirely using the bar model in this scenario. We can see that each of these other boxes 6, blah, blah, blah. Although, as I've said before, actually, what I would be doing here is saying, well, this is 5 times bigger than that, so that's going to be 5 times bigger than 6. And this is 3 times bigger than that, so that's going to be 3 times bigger than 6. And so what we've got here is, answer the question, work out the amount of money that Tom has. Doesn't really matter which one we use, whether we use the old ratio or the new ratio, because of course Tom's amount of money hasn't changed. Tom has £18. So when we move that into the abstract, and this is where we're going to be using the forming the equation. And the reason I would do this, even though we've solved the problem pictorially, the reason I would do this is because we're going to come to more complicated problems where the bar model is not so intuitive, is not so straightforward to model, is not so easy. So when we come to look at this in the abstract, I'm going to use my favorite device for working with ratio. I'm going to use the ratio table. And as you've seen in my previous videos, we've got Tom and Hannah here in the ratio 3:5. But then we've got a second ratio. We've got a second ratio, second bar model. And this is why I would use the bar model here to sort of aid this transition. We've got a second bar model, which means we're going to need a second ratio table. So we're going to need a before and after, if you like. This represents the ratio before the change. This represents the ratio after change. And I'm going to put the 1 to 2 in there, even though we've ended up with 3 to 6. I'm going to put the 1 to 2 in there because I want to show students here how we're going to transition solving these problems using algebra, which is going to be important later on. And so what I'm going to say here is, okay, well, we've got Tom and Hannah originally 3 to 5, and we don't know anything about the values here. We don't know Tom's part, we don't know Hannah's part, we don't know the total, we don't know the difference, we know nothing about the initial setup in terms of actual value. We only know the ratio. We don't know how much money we don't know anything about the amounts of money at this point. And what do we do when we don't know something? We have an unknown value in mathematics. Well, we tend to represent it with a variable. So I'm going to represent Tom's amount of money with the variable x. And then the key, again, relationship, which we've seen before if we've looked at my earlier videos about more simple sharing ratio problems, is, and we saw this in the bar model as well, we know that Hannah's share is 5/3 of Tom's share. Or Tom's share is 3/5 of Hannah's share, but because I've called Tom's share x, I'm going to use the 5/3. So this will now be 5/3 of x. And so now what I'm going to look at what happens to these values when we move from the before scenario to the after scenario. And in the before scenario, we had Tom with x, and we noted before that Tom's value hasn't changed. Yeah, Tom's value stays the same. So Tom will still have x. But what happened to Hannah is Hannah got that extra £6. So Hannah's, in this new scenario, is that original 5/3 of x that she had before, plus this extra £6. And those are what the values they have in the new ratio. But in this new ratio, we've got this new relationship, which the numbers have been chosen to make it quite a nice relationship, admittedly. But we've got this new relationship where Hannah's share is twice the size of Tom's share. Hannah now has twice as much money as Hannah has. And so what we can see here is that if we take Tom's share of X and we double that, that is the same as Hannah's share. And this is where we're going to form our equation for solving. And obviously, we can't do this with kids if they're not used to solving equations like this, particularly equations involving fractions. But this is how that follows from what we did over here. It's a slightly different process as it happens, but it's motivated by what we did over here. And it's an important step for kids to take. And so now we would go on to solve this equation. I'm not going to model solving the equation here. We do the classic things with times by 3, with times by 3 all the way across here. We'd do some subtraction and we'd arrive at the solution. Okay, which is a very simple x equals 18, as we saw over here. Tom has £18. Now, the reason I'm doing that, and the reason I do want to bridge this gap at this point, is because if we get right towards the top of GCSE with this, we're going to see situations like this where neither thing stays the same. And you can see this is a very similar problem now. Tom and Hannah still have that original money in the ratio 3:5. Tom gets an extra £10 and Hannah gets an extra £6. The ratio of their money is now 7:9. Work out how much money Tom has. And what we see here is now nothing has stayed the same. Tom's value has changed. Hannah's value has changed. Sometimes the total stays the same, and you could do something similar before that I did before, but by examining total. If Hannah gives money to Tom, you can normally just about get rid of model that through in a similar way with the bar model. Or if they both get the same amount of money, then you can model it with a bar model using the fact that the difference stays the same. But it gets quite complicated. And in this scenario, it gets really complicated to the point where actually I'm not even going to use a bar model at all for this, because the bar model doesn't really offer anything. And this is why I wanted to make this transition at the earlier stage, where I can still tie it back to the bar model. I can make that transition into the abstract so that by the time we get to problems like this, we're going to dive straight in with the ratio table. Okay, so, and again, because we've got two ratio, we're going to have two ratio tables. We've still got Tom and Hannah's before situation, and then we've got Tom and Hannah's after situation. And in the before situation, Tom and Hannah had their money in the ratio 3:5. And in the after situation, Tom and Hannah's money is now in the ratio 7:9. And again, if we look at the before situation, we don't know anything about the values here. We don't know anything about the actual money in this scenario. We don't know how much money Tom has, how much money Hannah has, how much the total is, how much the difference is. We know nothing. So very similar to what I did before, I'm going to say, right, well, we've seen this already. We've got Tom's amount of money as X, and therefore, because of that relationship, we know that Hannah's money will be 5/3 of X. And then we look at, okay, so how did those values change going from the old ratio to the new ratio? And going from before to after, Tom gained an extra £10. So his share, or his amount of money, is now X plus 10. And if we look at what happened to Hannah's amount of money went from 5/3 of X to an extra £6. So her share has gone up from 5/3 of X to that extra £6. But if we look at the ratio now, and again, I know I keep stressing it, but it's really, really important. The exchange rate, the functional multiplier, the multiplicative relationship between these values, is that this is 9/7 of that. Hannah's share is 9/7 of Tom's share. So what we're saying here is, if we take Tom's share, all of Tom's share in this new ratio, this x plus 10, and we multiply that whole thing by 9/7, then we will get Hannah's share. And this is why in every scenario before this, where kids have been working with ratio and solving ratio problems, this is why it's really important to have modeled using those relationships, because as well as I've said before, when dealing with proportion and y equals kx and those things, when we get to problems like this, right at the top end of what we're going to ask kids to do at GCSE or even at A level, when they talk about solving ratio problems which feature in A level, it's the understanding of that relationship between the parts that's absolutely crucial to forming the equations, solving the equations. And so again, we've got an equation formed here now. We're not going to model the solving of that equation. It's fairly straightforward. You'd start probably by multiplying both sides by 7 and by 3 or by 21 if you want to skip that and do that in one step. Expand the bracket, simplify and solve. You'll be able to solve that equation. And obviously kids tackling these sorts of problems need to be able to solve these sorts of equations, which is why it tends to appear right towards the top end of GCSE. So that is my shortish video on forming equations with ratio, or the relationship between ratio and equations. As always, I'd like to give a big shout out to Johnny Hall and his website, mathspot.com, which I use to produce all of the representations and manipulatives for supporting these videos. And if you've not been to Johnny's website, mathspot.com, then I would heartily recommend you check it out. You can see there we've got all the virtual manipulatives. The bar model was actually, I think, one of the tools. Oh no, there it is. It's in the bar model, but you've got tools in there as well, like angles, number lines, all sorts of loveliness there. You've got question generators, you've got tasks, you've got starters. If you're a maths teacher looking to save time with your planning and resourcing of lessons, this is 100% a website you should check out if you've not checked it out already. And as always, if you are interested in the use of representation, manipulative structure for teaching mathematics, then do have a look at my website, visiblemaths.co.uk, and among the many things you will find there, you'll find a link to my first book and some details about my first book, which is called Visible Maths, and is entirely sort of designed to help maths teachers to use representation, structure, manipulatives to support their teaching and to support kids making sense of mathematical concepts. So that's the end of my video. I hope you found that useful and interesting, and thank you very much for listening today.